Okay, students, so I'm going to go over review sheet 1 for third quarter. I'm going to go very quickly because you can always pause the video and back it up. And I recommend, if you haven't done some problems, that you do them first before watching me solve the problems. Okay, so we're on slide 1. Each slide here, each page will go to a new slide. Okay, write the slope-intercept form of an equation of a line given the points and the slope. Okay, so what we mean by that is y equals mx plus b. Also called the slope-intercept form. And we're going to, we always have to find m and b, right? So the answer is going to be something like y equals 3x plus 7 or y equals 4x for diagonal lines. These are diagonal lines. And I already know the slope, -2. So I already have part of what I need to find, but I also need to find the b. In order to find the b, I plug in any point. Sometimes they give us 2 points. In this case, they gave us 1 point. So I'm going to plug in the y value from our point and the x value from our point. And then I'm going to solve for b. Okay, so 4 equals 2 plus b. 2 equals b. Now that's not the final answer. The final answer is, of course, this, what we wrote here in black. We need to insert the m and the b that we solved throughout the problem. So the m was given to us. That was easy. The b we discovered by plugging a point in and plugging m in. So final answer is y equals -2. That's the slope. X plus b. B is 2. Okay, I may make a mistake through these problems, of course. I'll try to catch them all, and I'll mention them in class. But, you know, when you rush through something like this, it sometimes happens that I make a mistake. If that happens, just you can check it on Desmos. Of course, you can also check it on Photomath, and just ask me about it. And, of course, I'll clarify it if I find out I did make a mistake. Okay, next one is the same exact thing. So, again, the slope is 2/5. This one just has a little fraction work in it. X plus b. So we're halfway done, but we also need to find the b. And the b we have to find by plugging a point in. So 1 equals 2/5. Now I'm going to put the x in as a fraction because it's being multiplied by a fraction, right? This 2x, the m is multiplied by the x. So I'm going to put 2/5 over -5 over 1. And then, of course, plus b. Okay, and that's going to be -10 over 5 or -2. Plus b, and then I'm going to add 2 to both sides. So that's not our final answer. Our final answer is, of course, the equation of the line. I should have boxed this one for you so you know final answers are in boxes. Y equals the slope that was given to us, of course the x, and then the plus 3. Okay, this is a little different in that I want to find the same thing, y equals mx plus b, but I'm not given either one. I'm not giving m or b. I'm not given those two. I'm given 2 points. So we have to actually solve for the slope formula. Don't forget that all of these, I'm going to do it a little differently than this. All of these formulas and steps that I'm doing are all explained in our linear guide. Most of you have it downloaded in Notability. On your iPads, it's also, of course, in the notes. So I'm going to do y2, I always use parentheses here, you'll see why in a second, minus y1 over x2 minus x1. And that's the reason why we need the parentheses, because these double negatives will happen sometimes, right? So this is -2 minus 4 is -6. And this is 2 minus -4, so that's +6, because this is plus. Double negatives make a plus, so 2 plus 4 is 6. And of course, this simplifies to be -1. So now we have y equals -1. We don't normally leave a -1 here, but for this process we can. X plus b, but I'm going to put in a point. Actually, I meant to leave this as x first, right? So -1, x plus b. And then we're going to replace the y and the x, doing a little different this time with parentheses because sometimes that helps us with negative numbers. So I'm going to plug the y and the x. And now which point do you use? It doesn't really matter. I usually pick the smaller one or the one with easier numbers to deal with. So I'm going to take the second point, but you could plug the other point in and it will still work. Again, the y value goes here. That's the second number listed there. And then the x value goes here. And so I get negative 2 equals negative 2 plus b. I'm going to add 2 to both sides. And when I do that, I get b equals 0. So that means we're not going to list it at all. So actually the final answer is going to be y equals negative x. So the first thing I want to talk about here is that I'm dropping the 1. We don't include 1s, right? But the negative sign is there. So it's negative 1 because here's my slope, right? There's my slope. So I'm going to put negative 1x, but I don't write the 1. And then plus 0, but because we don't write zeros, we're just going to leave it like this. So y equals negative x is the answer. Okay, next one. Again, I'm looking for y equals mx plus b. I don't have either one, so I'm going to use my slope formula. So m equals y2 minus y1. Oh, I messed up, sorry. So like I said, I might make a mistake because I'm kind of rushing to get all this done for you. But hopefully I'll catch them all. Okay, over x2 minus x1. Okay, and I'm just going, just for, everybody should know this because it's just review, but that's x1 and that's x2, that's y1 and that's y2. Okay, so I'm doing y2 minus y1 over x2 minus x1. Okay, we got the double negative here, so that's negative 3 plus 1, so that's negative 2. And this is negative 5 minus 5 is negative 10, and that simplifies to be, right, positive. Negative divided by negative is positive, and that's 1/5. Okay, and then we plug that in, so we get y equals 1/5 x plus b. But now we're going to replace the y and the x with a point from our given points. Again, I'm going to pick, doesn't really matter which one. I'll pick this first one here. So I'm going to put the y value here and the x value here. Notice I'm going to put 5 over 1 because it's a fraction getting multiplied by an integer, so I want to get 2 fractions out of that. Okay, so that's negative 1 equals 1/5 times 5 over 1 is 5 over 5, which is 1. Okay, and then I'm going to subtract 1 from both sides, and I get b equals negative 2. So the final answer is y equals, take the slope from our first part, 1/5 x, and then plus b, which is negative 2. So that's the final answer. Okay, slide 2. So now they're telling it's parallel. So parallel lines have the same slope. So what we're going to do is, from this line, see, our line is parallel to this line, so that means this 4 is the same in our problem. So that means we have y equals 4x plus b. Now, a lot of people tend to put plus 5 here by mistake. Parallel lines don't have the same y-intercept. They won't. They have the same slope, but they won't have the y-intercept be the same. So I know it can't be 5, otherwise it would be the exact same line, right? So parallel lines have the same slope, see here and here, but they have different b's. So again, to find b, I just plug in the point. Don't use the 5. This has no bearing on the problem whatsoever. So I'm going to plug 3 in for y, and I'm going to plug in 2 for x, and solve for b. So 3 equals 8 plus b. That's going to be b, subtract 8 from both sides. b equals negative 5. So the final answer is y equals 4. That's the slope I got in the very beginning, which I just stole from the other line because they have the same slope. And then my new b for our line is this. And of course, if you plug in the original line and this line into Desmos, and you know how to use Desmos, just type in both lines, you'll see that they're parallel. And you'll see that this line passes through the point 2, 3. Okay, same thing again, except this is a special case. So anytime we have x equals 0, or x equals a number at all, that's a vertical line. So this line here is this line. It's right on that's a little mistake there. It should be on the x-axis, but that's just my pen is not too accurate, okay? So that's x equals 0. But it has to go through the point 4, negative 5, right? So 4, 2, 3, 4, and then negative 5 would be somewhere down here, okay? So I need a line that, and remember that this is 4, negative 5. That's important. So I need a line that's parallel to this vertical line. That means another vertical line, right? 2 vertical lines would be parallel. But it has to pass through this point, right? So that means it has to go like this and straight through that line. Okay, so basically the answer is another vertical line. So it's going to look very similar to this, where it's going to be x equals a number. And what that number is of course the x value in this point, because it's going vertically, right through that point. So all of the x values of all the points on this line is 4. So that's how we name another vertical line that's parallel to this original purple line here, or green as I drew it here, and passing through this point. Okay? Now, perp stands for perpendicular. We also use this symbol for perpendicular. You'll look in your notes like a nail on the ground upside down. Okay? So perpendicular slopes aren't the same as parallel. They actually are negative reciprocals. So that means that the slope of my line is going to be negative reciprocal of the original slope. So the original slope here is 4/5. So that means I'm going to get negative 5/4. The rest of the problem works the same way as we always do, which is just plug that in for m, leave the x alone and the b, and then we're going to plug in a point into our equation to solve for b. I didn't mean to. Okay, let's do it that way. I'm just going to change colors here a little bit. So I'm going to plug in for 0. I'm going to plug in for, okay, I'm going to plug in, oops, it's not changing the icon. All right, it'll work. I'm going to plug in 4, 0. 0 is the y value, and 4 is the x value, but I'm going to make this 4/1 because it's a fraction. Don't forget that's a 4 down there. It's just gotten a little messed up from this pen. Okay, so that's 4. Okay, so now 0 equals, now negative 5/4 times 4/1. The 4 is actually reduced, or negative 20/4 is negative 5. Plus b, add b to both sides, add 5 to both sides, excuse me, and you get b equals 5. Okay, so the final equation line is just the m that we found in the first part right there. So negative 5/4, of course the x, and then plus 5. Another way to write the line, you can write it like this too. You can write y equals negative 5x/4 plus 5, a little more compact way to write it, means the same thing. Okay, again, another perpendicular, so that means we're going to take this slope from this line, which is 2/5, and flip it and change the sign, negative reciprocal. So it's going to be negative 5/2. And then we're going to take our y equals mx plus b, and we're going to plug in that slope. And then we're going to replace x and y with the value from this point, right? So the y value is going to go here, 5. Keep the slope the same. And then we're going to put in the x value of negative 4. I am going to make this x value, though, right? That's the x value. And make that going to be a fraction. So it's negative 4/1 plus b. That's a 4. Okay? And, of course, negative times negative is positive. Okay? So this is going to be a positive number. It's 20/2. 20/2 is 10. So this is going to be positive 10 plus b. Subtract 10 from both sides. I get b equals negative 5. Final answer is just y equals the slope from the first part, negative 5/2x, and then minus 5. Okay, next slide. Evaluate each function. Okay, so all that means is this is what's getting plugged in for x. So in other words, I'm going to replace all my x's with negative 10. Okay, so I'm going to replace this x with negative 10, but I leave the negative sign there, and I put a parentheses wherever there's a variable, plus 1. And then I'm going to plug that negative 10 into there, right? So that's negative 10. Okay, so that's basically double negative makes it positive, and of course that's equal to 11. Okay, so k of negative 10 is equal to 11. Okay, p of x equals 3 of x, find p of negative 6. So that means I replaced my x with a negative 6. So the negative 6 gets placed into both x's. So basically p of negative 6 equals 3 times, that's an equal sign there, 3 times negative 6, which is negative 18. So that's the answer for p of negative 6, negative 18. Okay, here h of negative 1 equals, notice how I leave the negative sign alone that's in the beginning of the problem. I keep the squared symbol, minus 3, and then I plug in this number, right? Negative 1. Now, PEMDAS says you got to square first. So negative 1 squared is right? Negative 1 squared is 1. Notice I don't drop parentheses until after multiplication is done. That was E for exponents, so we didn't finish multiplication. Now I drop, because negative 1 times 1 is negative 1. Now I drop the parentheses because multiplication is done, and of course it's negative 4. So h of negative 1 equals negative 4. Okay, here h of 10 equals negative 10 squared minus 10. Okay, so 10 squared is 100, so negative times 10 squared, or negative times 100 is negative 100 minus 10. Dropping parentheses because multiplication is done, negative 110. Okay, h of negative 4/5 equals negative 2 negative 1/4 times a, but a is negative 4/5. Okay, so that equals negative 2. Negative times negative is positive, so that's going to be a plus. The 4's reduce, so it's going to be 1/5. Now, we have to convert negative 2. We need like terms here. We need common denominator, excuse me, here. So I'm going to turn negative 2 into fifths. Okay, so I'm going to multiply top and bottom. I'm going to put this over 1, multiply top and bottom by 5. So I'm going to get negative 10 over 5, because that's equal to negative 2, plus 1/5. Okay, and that's equal to negative 9 over 5. And that's the answer. Okay, g of 1/4, that's a 4 there, sorry, equals 2 times 1/4 squared plus 3 over 2 times 1/4. Okay, I'm going to make this 2 over 1. So g of 1/4, again, sorry about the typo there, equals, now 1/4 squared is 1/4 times 1/4. 1/4 times 1/4 is 1/16. Sorry about the 4 there. So this is 2 over 1. Notice the parentheses do not drop yet. Over 1/16 plus, and I'll do this multiplication later because I'm in the E stage. I'm still doing exponents. Okay, 1/4. Okay, g of 1/4. Yeah, that's my pen making that mistake there, so I apologize about the 4's. 2 over 1 times 1 over 16 is 2/16, which is 1/8. Plus, and this is 3 times 1, that's 3 over 8. This was a 4 if you remember up here, right? So 2 times 4 is 8, so that's 3/8. And 1/8 plus 3/8 is 4/8, but 4/8 reduced to 1/2. So 1/2 is the final answer for g of 1/4. That's a 4. Okay, next slide. Find the slope of each line. So we're just going to count boxes here. Okay, I'm going to count boxes. So I'm going to start from a point here, and I'm going to go to the next point that goes through a corner. So that's going to be down 1, right 1, right? So not up, but down. So down 1, right 1. That's positive. Right is positive, down is negative. So basically the slope equals -1. Okay, and I want to write equals m. I'm going to usually put that in the beginning. Okay, here m equals, and by the way, there's 2 blue dots here. You could have gone and done all of these. So you could have gone down, I think that's 8. Let's see, yep, you could have gone down, no, it's actually 7. Down 7 and then right 7. Oh, actually, you know what? I did this one wrong because it's not going through the corners. Okay, yeah, so glad I caught that. See, I'm rushing. Okay, so my bad. We do need to be careful here because I thought this was going through the corners, but I misjudged it. So what I need to do is count how many boxes from here to here, and that is down 1, 2, 3, 4, 5, 6, 7. So that's down 7, so -7. And then it's over from that position 1, 2, 3, 4, 5, 6, 7, 8, 9. So from there to there, across is +9, 9 to the right. So the final answer for this is -7, down 7 over 9. Yeah, so use the blue dots. Otherwise, you're guessing that it's going through the corner there, but it's actually missed the corner a little bit here, so I shouldn't have never done that. So same thing here. I'll use the 2 blue dots, and I'll ignore, because these aren't going through any nice corners here. So from this dot, I'm going to go up 1, 2, 3, 4, and I'm going to go over 1, 2, 3, 4, 5, 6. So up 4, right 6 is 4/6, which reduces to 2/3. This is a vertical line, so you don't have to really do anything. You know all vertical lines have an infinite slope, or undefined is really the right answer because we don't talk about infinity as a real thing. So undefined. It just means it doesn't exist. Okay, it's an impossible slope going vertical. And horizontal lines always have a slope of 0. Okay. Yeah, I'm not in class cake. All right, here we go. All right, system of equations, right? There's a few ways to do them, and we'll talk about the different ways. But they want us to do substitution, so we have to stick to substitution. So substitution means you have to get a variable by itself, which I already have right here. That's good. And then you take the other side and plug it in for that variable, right? So this thing is going to go down into that y right there. Okay, that's what substitution method is. Again, if this was from scratch, I'd be teaching you this a lot slower, but this is all review, so you can always go through your notes again, and I think this makes sense once you have done this before. So again, I'm going to substitute this expression in for that y. And the way I do that is I bring everything down, 2x minus 2, but as soon as I see the y, I put a bracket or a parentheses, make it wide enough, and then I bring down everything else. So all I did was take the y out of the second equation, made it a blank parentheses, and I'm taking the y value from the original and I'm putting it inside that parentheses. Okay, and then I only have x's, so I can solve for x. So it's 2x. I have to do multiplication here. So it's minus 2 times minus 2, distributive property here, is positive 4. And then negative 2 times 1 is negative 2, equals 4. Okay, so that's 2x plus 2 equals 4. 2x, subtract 2 from both sides, equals 2. X equals 1. It's only half the answer, though. I need to know, right, what y is equal to. So I'm going to take this first equation. I could actually do either one. But this first one is set up so nicely because it already says y equals. And I'm going to plug my answer here in for x. Okay, and I'm going to get y equals negative 2 plus 1, which is y equals negative 1. So the final answer is actually a point, because when they're saying solve the system by substitution, they're saying solve the intersection of these two lines. And so the final answer is 1, negative 1. It's a point. That's the point of intersection. Okay, 20. Again, y is already isolated. It's very easy, so it's really the same exact thing we just did. We're going to just plug it in, just a slightly different equation. So I'm going to go quickly here. Wherever there's a y in the second equation, I'm going to put a big parentheses. I used a parentheses instead of a bracket this time. And I'm going to plug the y value in from the first equation into here. Okay, so it's negative 5x, distributive property, so negative 10x. Distribute this next, negative 20 equals negative 5. Okay, like terms here, that's negative 15x minus 20 equals negative 5. I'm going to add 20 to both sides. I don't usually show that step, but I'm doing it here. Equals, so adding 20 to both sides, so that's going to be 15. And then I'm going to divide both sides by negative 15, which is the number in front of the x here. And I'm going to get x equals negative 1. Again, I'm going to take the original equation here, plug negative 1 in for x, because that's what I solved for, and then I'll be able to solve for y. So y equals negative 2 plus 4. So y equals, careful, that's a plus, 2. Okay, so the final answer is the point negative 1, 2. That's the final answer. Okay, over here, there is no variable solved for, but x is alone in that it has no coefficient. So I'm going to get x by itself. So I'm just going to subtract 3y from both sides. So I'm going to get x equals 7 minus 3y. You could also put negative 3y plus 7. So in this equation here, I solved for x up here. That's x. So whenever I hit an x in this equation, I'm going to leave a big blank. But other than that, I'm going to leave the equation the same. Okay, so this x goes in here, and it's going to be 7 minus 3y. Okay, that's negative 28 plus 12y. I'm bringing everything else down. And then like terms go together, so this is minus 28. That's negative, positive 12y minus 8y is plus 4y. Add 28 to both sides. When I add 28 to this, I get 8, so 4y equals 8, and y equals 2. Usually these are integer answers. It could be fraction, but at this level that we're doing, just algebra 1, probably going to be an integer. So if you don't get an integer, it's a good sign it may be wrong. I'm going to take this 2 and I'm going to plug it in for y, because that's what y was equal to. So I'm going to do x equals 7 minus 3 times 2, which is 6. So that's x equals 7 minus 6, which is 1. So the final answer is 1, 2. The x always goes first, even if you solve for it second. That's the intersection point. Here, we're going to get x by itself again at the bottom. This is the easiest one. So I'm going to add 8y to both sides. So I'm going to take the top equation and replace x with a parentheses. And now I'm going to use the bottom equation, which I've got, right? I'm going to move this over here. So I'm going to get x equals 17 plus 8y. And so that's what I'm going to plug in here, 17 plus 8y, because that's what x is equal to. And then I'll solve for y. So this one's a little different in that I isolated x from the second equation, and then I plug that x value into the x of the first equation. Okay, so that's minus 34 minus 16y plus 16y equals negative 34. Okay, now this goes away completely. Those are opposites. So I get negative 34 equals negative 34. When that happens, that's a special case, right? That means it's always true. This is always true, which means that these two lines always intersect. And the reason for that is they're the same line. If you were to get these into y equals mx plus b format, you'd notice that these are the exact same line. And if you sketch both of these in Desmos, you'll see that they're overlapping each other everywhere. So when you get two numbers that are equal to each other like this, that means always true, or it really means the same line. All numbers on these two lines are the intersection points. So basically the answer is the same line. Okay, next slide. This is elimination method. So elimination method is we try to get one of the variables to cancel out. So you can see here, if I multiply this top equation by 2 on top and bottom, by 2, you'll see that the equation will look very similar. So I'm going to get minus 2x plus 20y, there it is, that matches, equals negative 20. And then I'm just going to recopy down the second equation as it is without any changes. And, oh, I made a mistake. I'll explain my mistake in a second, okay? Okay, so here's the problem with my mistake here. If I was to add these, I'd get 40y. I wouldn't get rid of a variable, and I'd get negative 9x. I wouldn't get rid of a variable. So the mistake was that I should have multiplied this by negative 2, not positive 2 on both sides. And that will get it so that our two variables are opposite. Okay, so I really want to multiply by negative 2 on this side and by negative 2 in the front here. Right, so I'm going to distribute that negative 2. So this actually becomes positive 2x, and this becomes negative 20y, so that's positive 2x minus 20y, and then of course negative 2, this is a negative 2, times negative 10 is plus 20. Okay, so now that I have one variable's coefficients to be the opposite sign but equal, which is the case with the y's here, you can see it here. Okay, now I'm going to just add. So 2x minus 7x is minus 5x. Minus 20y plus 20y is 0. That's what I wanted to happen, so that one of the variables went away. And then 20 minus 20 coincidentally is equal to 0. So I get negative 5x equals to 0. I'm going to divide both sides by negative 5, so I can get x by itself. And what do I get? X equals 0. Okay, I can take that x equals 0, plug it into either equation, and solve for y. So I'm going to take the top equation, and I'm going to put 0 in for x. So I'm going to get negative 0 plus 10y equals negative 10. Of course, 0 doesn't matter, so I'm just going to divide by 10 on both sides, and I'm going to get y equals negative 1. So the final answer is 0, comma, negative 1. Okay, over here, it's much easier. I'm just going to multiply both sides by 2, kind of like I tried to do earlier, but I was wrong. But now I'm correct. So I'm going to multiply this side by 2 and this side by 2, and you'll see what will happen. So the top equation will become negative 10x minus 6. No, I did it again. Yeah, it won't work. I need to multiply it by negative 2 again. Okay. And then I'm going to get positive 10x plus 6y equals positive 38. And then I'll just rewrite the second equation. But you'll see we've got some weird things happening here, some trouble here, because both of these are opposite. So something very strange is going to happen. Okay, so let's do it. So I put my line here, I add vertically, I get 0, and then I get 0 again equals, and this is going to be negative 10. I mean positive 10. Okay, so I get 0 equals 10. So unlike the problem on the other page, this is never true. And what kind of lines would never intersect? Parallel lines. Okay? Parallel lines are the only type of lines that don't intersect. Right? So if I had a graph here like this, and of course I don't know, I'm not looking at these lines in detail, but if I had two lines like this, they would never intersect. So if somebody said, hey, solve this system, tell me where these black lines here intersect, the answer would be never. So that's why parallel lines is the answer when you get two numbers not equal to each other, supposed to be being equal to each other. That means it can never happen. Okay, down here, this is really out of scope of our course, so I'm just going to leave it because you'd have to multiply the top one, for example, by 4 and the bottom one by negative 7. And we're not going to have that on our exam. So, I mean, you're welcome to come by after school if this is more of like a C-type problem, but I'm not going to waste our time studying for the exam for this one, okay? It's good practice anyway. Same thing with this one. These both are tougher than we're going to have in the exam, so I'm not going to cover those just to save you time. But again, I will go over these in class if you want to ask about them. Okay, let's go to exponents. So 6 to the 5th over 6 to the 3rd is kind of like saying 6 times 6 times 6 times 6 times 6 over 6 times 6 times 6. And as we know, when you divide, any two things that are the same, when they divide, these reduce to 1 over 1. These reduce to 1 over 1. And these reduce to 1 over 1. And so I'm left with 6 squared. And we happen to know what 6 squared is, so we're going to say 36. Okay? The other way to do the problem is that we know that when we divide bases that are the same, we simply subtract the powers. So 6 to the 5 minus 3, and 6 to the 5 minus 3 is 6 squared, which of course is 36. Okay, same thing here. We could do 4 minus 7, but it's a little bit longer to do that way, so it's better to just think of it this way. And you don't actually have to write this out. You can just picture 7 at the bottom. I'm writing it out for you. Okay. And you could say, oh, okay, these reduce, these reduce, these reduce, these reduce. So I'm left with 1 over. Now you got to replace them with 1s. That's important. Otherwise, you'll forget that there's a 1 in the numerator. So 1 times 1 times 1 times 1 is 1 over 1 times 1 times 1 times 1. Don't care. That's just 1 times x 3 times is x cubed. Okay, anything to the 0 power is 1. You just have to memorize that. Okay, here, right? So we would have x times x, and then 5 y's, 5 multiply together y's, right? Not 5y, that's 5 y's, big difference, right? And then 4 y's down here. And then you can just picture that one of the x's reduces, and 1, 2, 3, 4 of the y's reduce. So all you're left with is xy in the numerator and 1 in the denominator. These are all 1s, but we're not supposed to leave 1s alone in the denominator, so we just write xy. Okay, here we're going to use the power. We could write this out 3 times. We could write this parentheses 3 times and do it that way. That is the long way. I'm going to kind of do the short way for this one. So you can multiply this exponent by the exponents of all the variables in the top and the bottom. Okay, so this is 4 to the first power. So 4 to the first, 1 times 3 is 4 to the third power. And then x to the fifth times 3 is x to the 15th. And then y to the third. And if you do it the long way, it'll also work out this way. Now you get 16 to the third times x to the third times y to the 12th. 4 times 3 is 12, okay? All right, now a lot of things happen here. So I'm going to go a little quickly here, a little quicker than the other one. We can do the rule here that says when you're dividing by the same base, then the exponents subtract, right? So 15 minus 3 is 12. So I know I'm going to get an x to the 12th in the numerator because this was higher. And in the denominator here, 3 minus 12 is negative 9, but negative 9 means it moves to the denominator. So this would be y to the 9th in the denominator. Okay, you can just tell. There are 12 down here and 3 down here. You know there's going to be 9 left over, and they're at the bottom because there's more at the bottom. And then this one's a little tricky here. It is 4 to the third times 16 to the third, right? But, and I think I'll leave it like that for now because it's probably out of scope of what we would see in the exam. But I'm going to do it anyway. 4 to the third is really 4 squared times 4, right? And of course, I'll leave this here. And 16 cubed is 16 times 16 squared. Okay, and if you're wondering why I'm doing that, I'll show you that in a second. And of course, 16 is 4 squared, right? So really, I could have written right here, I could have just put 4 squared, right? And you know that 16 divided by 16 is 1. So we simplify this greatly. Also, this is 16 times 16. I could have gone, probably should have done this a little further. So I'm going to do 4 equals 16 times 16. Okay? I don't mean to put an equals there. Times x to the 12th. We don't lose this over y to the 9th. So this will reduce as 2, right? So 4 and 16 reduce to 1 over 4. Okay? So ultimately, and there's a faster way to do that. I'm just kind of showing you this one particular way. So 16 times 4 is 64. So that's your final answer. It's kind of a C, late B, C problem because of the numbers, because the numbers are a little challenging here. Okay, let's go to the next slide. Anything to the negative power means move it to the bottom if it's at the top, or if it's at the bottom already, move it to the top, right? Move it to the opposite side of a fraction. So the first thing I need to do is write this over 1 so that it becomes a fraction. And then I say, oh, the negative 7 moves that to the denominator, but there's always a 1 in the numerator. You can't have a blank numerator here. It doesn't just become y to the 7th, which a lot of people put. That's a very common mistake. Okay, 7 to the negative 2, same thing. 7 to the negative 2 over 1. And then I'm going to move this, I'll leave a 1 at the top and move the 7 to the negative 2 at the bottom. Please note, I didn't really move this 1 to the top. It's just that there's a 1 always at the top. So this 1 is still here. It's 1 times 7 to the, oh, no, by the way, that's a big mistake. Sorry, God, caught that. That's squared. I already used up the negative to move it to the bottom. When I move the negative 2 to the bottom, I use it up. That's what the negative does. It moves it to the bottom, so it's no longer that. This 1 can be confusing, so I'm just going to erase it, but just to show you that. And of course, that's 1 over 49. That's our final answer. Here, it's already in a fraction form for you, so all that does is it makes the x to the 5th go to the numerator. Okay, there's always a 1 in the denominator. It's not this 1. I'm not moving that 1. That one's not moving, but there's a 1 here. But of course, we never write anything over 1, so we write x to the 5th. But you really want to keep these as fractions till the very end. Okay, same thing here. So this is going to equal 2 to the 4th over 1. But I'm going to make that equal to 2 to the 4th. And by the way, I mean, you know what 2 to the 4th is, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. So you can write 2 to 16 at the end. Okay, here, when we multiply with the same bases, we can add the exponents. This is really x to the 5th minus 1. We're adding 5 and negative 1, which is x to the 4th. Another way to think about it is start with x to the 5th, but move that x to the minus 1 to the denominator so it looks like this, right? And then, of course, if you do the expansion method, which you don't have to do, but it's always a surefire way to do it. You're like, oh, these reduce, and I'm left with x to the fourth, which is exactly what we had. Okay, x to the sixth. I think by now you're getting the hang of this. This is just going to be 1 over x to the sixth. And then these two, we're going to just do the simple way. So it's 9 minus 7, so that's x to the second. Okay. Write a graph and equation that goes through the given point A that's parallel to the original line. Now the problem is this isn't in a form where I can see the slope, so I'm going to change this to be slope intercept form. So I'm going to subtract 2x from both sides. Notice I want to keep it in the front because that's closer to the right form. Okay. So again, all I did here is I subtracted 2x from both sides. And then y has to be y equals, right? We know what it looks like. It looks up at y equals mx plus b. There can't be anything in front of the y here. There can't be anything but a 1. So I'm going to divide everything by 3, all the terms by 3. Okay? Basically, I get y equals negative 2/3 x. Yes, I took the 2 out of the numerator, but that's legal. And then plus 3. Okay? And then to graph that, it's going to be y equals, it's going to go through at 3, and it's going to be negative 2/3. That means down 2 over 3. And again, this is the original line. This is not the solution to the problem. Okay? I'll take my straight line tool and try to hit all the dots. Okay. But I want my line, right? I want my line, let's see if I can pick green here. So I'll make green. I want my line to be y equals mx plus b. Okay. I'm going to plug in 0 for y. And I'm going to plug in negative 3 for x. I'm taking that from up here, right there. Plugging in. And my m, though, because it's parallel, is the same as in the other one. So it's going to be negative 2/3, the same as the other line. Now, I really should have put this over 1 to make my life easier, which I'm going to do. So 0 equals. Here, the 3's reduce. The negative times negative is positive. So basically, I get 2 plus b, which makes b equal negative 2. So the final answer is y equals negative 2/3, because parallel lines share the same slope, x minus 2. Okay. Over here, this is almost in y equals mx plus b format. So all I have to do is add 1/2 x to both sides, right? I'm going to add 1/2 x to both sides. Notice I'm putting in the front. And I go, oh, my slope is 1/2. So I already know my slope is 1/2. Okay. Oh, by the way, I didn't graph this other line. Sorry. So it would be down here at negative 2. And then it would be the same slope, down 2 over 3, down 2 over 3, and then I would connect them. See if I can make a green line for you. And it would go something like that. Okay, for this one, we have the slope so far. Let's find the y-intercept by plugging in our point. So it's going to be y equals 1/2 x, but a different b. So I'm going to plug a y value in. Of course, this is the point I'm plugging in. So it's negative 1 equals 1/2 times 2. But I'm going to make it 2 over 1 because we have a fraction, plus b. So negative 1 equals 2 over 2, which is 1, plus b. Subtract 1 from both sides. b equals negative 2. Final answer is y equals 1/2 x minus 2. I'm not going to graph both of these because you can check your work in Desmos. Okay? And just save a little bit of time so we can get through all the problems. Okay. Perpendicular to x equals 5. If you remember, x equals 5 is a vertical line, right? So I'm going to draw that roughly here. My pen is not great for sticking right to the line, but you get the idea. And then it's going to go through the point negative 2, 6. So negative 2, 6 is right here. So basically I need a second line that is parallel to this green line, and it passes through negative 2, 6. There's negative 2, 6. So a line that's parallel to the green line that passes through that point would be here. And the name of that line, like all vertical lines, is x equals something. And that something is what all the x values are along the line, and that's negative 2. Okay, perpendicular, so I need to get y by itself. I'm going to subtract 2x from both sides, putting it in front. I'm dividing by 3. And I get y equals negative 2/3 x plus 3. Okay, then I'm going to plug a point in. Oh, well, I'm sorry. So we're going to steal the slope. This is perpendicular. So we're going to take this slope and flip it and change its sign. So it's going to be positive 3 over 2. Positive 3 over 2. Okay? And then we need to find b. Because we found the m of our line, we need to find b. So it's going to be y equals 3/2 x plus b, parentheses plus b. Okay? And I'm going to plug in the point -5, the point -4, -5, which goes in like this. Put this over 1. So I get -5 equals -12 over 6, which is -6 plus b. I'm going to add 6 to both sides. B equals 1. Final answer, y equals 3/2 x plus 1. I'm not going to bother to graph these either. You can check them on Desmos just to save a little bit of time. Okay, really quick on this slide, let's take a look. Which of this following is not a function? So this one is not a function, D, because it fails the vertical line test. If I draw vertical lines, they only hit one red dot at a time, right? But here, if I draw that blue line, it hits a lot of red dots, and so that's why it fails the vertical line test. Okay, which of the following is not a function? So same thing here. You see how one x value had multiple y values, right? We can't have that. So if you look here, there are 2 points, right? 1, 5, and 1, -5 that would be directly vertically above each other, right? That would fail the vertical line test. So this is not a function. This one has also 2 x values that have different y values on them, so that's not a function. This guy looks fine, and this one is this, and this one is not, right? So these 2 points are above each other vertically, right? So that means there's 2 y values here for 1 x value, -4. So that fails, so the answer is C. Select which graph or table that is a function. You must select all correct answers. Okay, so this is a function because it doesn't fail the vertical line test. Okay, so that checks out. C is fine. This checks out. It's, again, passes the vertical line test. E fails the vertical line test. You can see when I draw a vertical line, it's going to hit 2 stuff, so I'm going to turn that one off. Okay, B has 2 places where there's an x value of 6, but there's 2 different y values. That's no good. This one looks fine. That looks fine. And this one also looks fine because all the x values are unique, so you're not doubling up. Okay, so it looks like the answer is, I didn't circle, looks like A, C, D, and E. Sorry, F. Set of orders pair is a function which could be the 5th ordered pair in this function. All they're saying is which one of these will not cause this to be a, which one of these will not break it from being a function. So if you look, this guy wouldn't work because there'd be 2 x values that are the same with 2 different y values, so he doesn't work. This guy also would be a problem because these 2 points would have the same x value, right? But 2 different y values. That's illegal. And this guy would also match. See, he's going to match that guy, so he's not good. So the only possible answer is A. Okay. You don't want to worry about this linear stuff. I was trying to actually think if they were trying to form a line, but they're not. Okay. Next slide here. Set of orders pair is a function which could not be the 5th pair. Same exact thing we just did. You're looking for duplicates. There's one that's duplicated with that. No good. This one's duplicated. It's not duplicated. Okay. Oh, it says which could not be the 5th. So these are all fine. I can see those are all fine. This one is the answer because that could not be the 5th. The word not is here. Set it order of pairs below is a function which of the following could be the value of x in the fifth ordered pair. Select all correct answers. Okay, it can't be 1 because it would match this 1 there. It can be 0, that's okay. It can't be 2 because it would match this one here. It can be 3, it can be 4, it cannot be 5 because it would match this one here. It cannot be 7 because it would match this one there. So all the other ones are fine. So 0 is okay, 3 is okay, 4 is okay, 6 is okay, 8 is okay, and 9 is okay. Fill in the table to create a relation which is equivalent to the graph below. Okay, so y value of 0, and that looks like 1, 2, 3, -4 in the x direction. 0 of x would produce a 2 in the y direction. Who has a y value of 3? This point, he's -2. At x equals 2, there's a -1 y value, and this last point here is 3, 1. Which relation is equivalent to the following set of ordered pairs? Okay, we're just we're just looking to match points here. So 2, 0. So you see 2, 0. This guy does not have a 2, 0. If you look, 1, 2, 0, there's no dot there either. So those guys can't be it. These two both have that. That's right there. Okay, that's okay, 2, 0. But let's try 3, 2. So this guy has 3, 2. This guy does not here. This guy does not have the point 3, 2. This guy does. So the answer is A. And that's all the slides. Okay, I hope that was helpful to you. I went a little quick because it's mostly review, and I skipped a couple of problems that really wouldn't be on the exam. They're a little more C-type problems. The exam will have all A and B problems only. Again, if you have any questions at all, and it's very possible I made a mistake as I'm rushing through, just ask me or check it in Desmos and check it on Photomath if you need to as well. Okay, good luck in the exam. Look forward to part 2 video.